Electric fields and the other fields are completely invisible. For this reason, IB examiners they always love to give this type of questions where you have to compute and determine the position where the field strength is maximum or minimum. So in this question, as you see, we are given the two charges, neg 5 microcoulomb and negative 2.5 microcoulomb. Both are static charges, so both will create their own electric field strength. So we have to determine that what at what position a, B, C, or D among all of these where the field strength is maximum. So it is not difficult. It is very easy. But the main thing for which you should not skip the video is we will calculate the electric field strength in terms of E. So you see here that we will try to find out the direction as well as their magnitude separately for all of the options. So let's start with the A. We know that electric field due to the positive charge is always away from the charge. So when I will try to draw a vector due to this positive charge, so I must draw a sign that represents the electric field strength vector away from that. And since this is a negative charge, so its electric field strength should be towards because field is towards, right? So obviously you see that the two vectors are in opposite direction. That gives us a least possibility that it may have a maximum strength of the magnetic field. So it should not be A. Let's check the option B. Now for the option B, since it lies exactly with between the positive and negative charges, where the electric field has its maximum strength because the field is in a form of straight line almost and it is uniform in the middle. So it should be maximum at the B. So this is the direction. This is the electric field due to the positive charge that is away from the charge, and this is the electric field due to the negative charge that is towards the negative charge. And you see that the two vectors add up and they must give us a maximum strength. Okay, now let's check the option C. Now, for the option C, if you notice that from the positive charge, the electric field should be directed away, right? And due to the negative charge it is towards. So it is giving us a situation in which the two vectors are not giving either a maximum value nor minimum value, but it is surety that C is also not an option because they are not giving us a maximum answer. Now what about the D? Now for the D, due to the positive charge it will be away, but it will have a less value because D point is distant from that positive charge, whereas for the negative charge it is towards. So it is again, you see, the two vectors are in opposite direction. So only the right answer should be option B. But important part of the video is starting now because I'm going to calculate in terms of E. So let's calculate. But look at one thing, that it is not a coincidence. They have intentionally given us in such a way that all the points from the charges are at a same distance, right? This distance and this distance is equal. This distance is also equal. All right. So it means that if I imagine that, let's say if I say this distance is D, the point C is at distance D from the negative charge, and so at that point, the direction of electric field is towards the negative charge due to the negative charge, and its magnitude should be E is equals to K Q. Remember, I'm writing the magnitude. I'm not using negative sign. KQ over D square. Okay. It means that when I will talk about this distance is D as well. But now this time, due to this positive charge, which is two times more in magnitude than the negative charge, so don't you think that at that point it must produce an electric field two times of E? Okay, because it is K into 2Q over D square. So that should give us 2E. Okay, so if you understand this thing, now we are ready and we can start one by one from the option. So positive charge is at a distance d, whereas the negative charge, can I say it's at a distance 3d? You can see the question that it is a distance 3d. This d this D as well as this D, right? So it means that we have already computed that due to the positive charge, this electric field strength has a magnitude 2E. So what about this electric field due to the negative charge? So we can quickly calculate it. It should be equals to K into Q because it's a negative charge, magnitude is Q. So over 3D whole square. So that should be equals to KQ over 90 square. That should give us E over 9, right? So which means that if it is E over 9, then these two vectors are in opposite direction. So that's why the net magnetic field strength must be 2E minus E over 9. So which gives us, dear students, 17E over 9 is the net electric field strength at the position A. Okay, now let's talk about the B. Now, I told you that for the option B, since the two fields are in same direction, so they must give us the maximum value. And whereas you know that this distance is D, whereas this distance is also D, right? So so if you remember, we have already calculated due to the positive charge, it is 2E. So that I'm going to draw here. Due to the positive charge, it is 2E. Then due to the negative charge, which is half of its magnitude, right? Negative 2.5. So it should be just E, right? Because its charge is half, whereas the distance is same from both charges. So it is E. So don't you think the net magnetic field strength is equals to 3E? That should be a maximum answer. Now, I hope you understand the pattern. I'm just going to show you the rest of the thing. So you can see that due to the positive charge, the electric field at the position D is just 2E over 9. I have put the value 2Q and the distance 3D and took it square. Whereas due to the negative charge, it should be E, right? Which you know that. So, so it is so at D, it is 7E over 9, which is also less than 3E. And at the option at the point D, you don't need to calculate because I told you that these two vectors are not in same line. So it cannot give you the maximum. So the option B is the right answer. Last but not least, kindly note down I have calculated electric field strength due to the both charges. So you can see it is not giving us a maximum value.